Today you are reviewing and preparing for your learning check on objectives 3.3, 3.4, and 3.5 tomorrow. So if you turn to your Unit 3, Day 9 practice in your packet or on Class Kick, we'll take a look at a couple of problems together to make sure you're on target with the objectives, and then you'll use the rest of the time to work on the remaining problems to still prepare for your check tomorrow. There are jumbled answers posted on Class Kick as well as the self-checking feature. Just make sure that you are following the directions posted on Class Kick about how to be entering in your equations so that the self-checking feature will work. So let's start off with some of our selected problems here for our sample. So for number 1, we're asked to write a linear equation for the given information. We have a slope of 2 and a point at 0, 1. There is a graph provided, so you could plot the point 0, 1, and from that point use your slope 2, going up 2 and to the right 1 each time to generate more points. Remember, anytime that you are graphing a line, you should have at least 3 data points there. The more points, the better for the accuracy, but that would be a visual for us, right, of the line, but we want to write the equation, and we know that we can write the equation several different ways. We could write it in slope-intercept, point-slope, or in standard form. The two most commonly used are, though, for when we're asking to write it, would be slope-intercept. That means if you have the slope and the y-intercept, or point-slope, the slope and just a point on the line. So if I'm looking at what I'm given here, I recognize I have the slope, and this point happens to be a y-intercept because the input is 0. So this would be very easy to put it into slope-intercept form. And so my slope is 2, I'll place that where n is, and then I want the y value for the y-intercept, which is 1, and so I could write my equation as y equals 2x plus 1. If you didn't recognize that 0, 1 was the y-intercept, whether you looked at it graphically or just looking at the givens, you could also write this in point-slope form. And remember, point-slope form is y minus y equals m times x minus x. And so our point 0, 1, the x was the 0, the y was the 1, and this would be our format. Now, anytime you have 0 in your equation, it's not going to impact your results. It's not really there, so I would simplify this and have it be y minus 1 equals 2x, essentially bringing you back to where you were with your slope-intercept form. If we look at number 2, we have a slope of 4/3 and a point of -6, -9. So again, one of two things. I could plot my point, -6, -9, and from that point go up 4 and to the right 3 to get a visual. So my visual would look like this. Here's my point, -6, -9, going up 4 to the right 3. There is my line. And if I look here, I can see I've confirmed with my slope that I know my y-intercept is at 0, -1. So I could write the equation in slope-intercept form, and I would write it as y equals 4/3 x minus 1. If you didn't want to make that visual to find the y-intercept, this would be perfect for point-slope format, right? Y minus y equals your slope times x minus x. And so I could just substitute in what I want. So with this point here, -6, 9, I would put -6 here, and the x, I would put -9 here for my y, and simplify to get my equation. Now remember, subtracting a negative is saying taking the opposite of what you have, and that would be a positive. So really, it should be y plus 9 here, x plus 6 here. So your final equation would be y plus 9 equals 4/3 times x plus 6. Looking at our number 4, we have 2 points. And so remember, anytime we're trying to write the equation of a line, we always need 2 things. We need a slope, and we need either a point or a y-intercept. So having these 2 points here, I can find the slope, I can do it algebraically, I can do it graphically. And then if I'm graphing, I could look to see if based on the slope and these points given, will I know the y-intercept? If not, I could put this in point-slope form pretty quickly. So for my graphing folks, if you plot your point at 4, -4 and 7, -5, we can see that we're going down 1 into the right 3. So our slope would be a negative 1/3. I also could have done it algebraically by doing the change in y over the change in x. That's why I have negative 5 minus negative 4, and then 7 minus 4, giving me that same slope. Now, looking at the graph, I can see I do not know the coordinates for the y-intercept, so slope-intercept form is not going to be useful. Next best thing, point-slope form. So I could use either of the points to write my equation because I have my slope. So if I want to use my one equation with the 4, negative 4, I substitute my 4 here with my x, my negative 4 here for y, and since I was subtracting a negative, that's a positive. So my simplified equation would be y plus 4 equals negative 1/3 times x minus 4. If I want to use the other point, 7, negative 5, I would have y plus 5 equals negative 1/3 times x minus 7. Now, if I look at number 8, I want to write a linear equation based on my givens, which happens to be a graph. And again, we're always interested in the slope, that rate of change, and either a point that I know on my graph or the y-intercept. And so I can see the y-intercept is here, however, it is not a grid point, so that's not helpful for me. So what I want to do is find some other points on my line that I know the coordinates of, so I could work on finding the slope, and then use that to write the equation in point-slope form. So 2 points that stood out to me was the x-intercept at 1, 0, and then my point at 5, 1. And I'm going up 1 into the right 4 to get to my next point. And again, I could see that I had this point here as well, negative 3, negative 1, up 1 into the right 4 to confirm my slope. So I could use my point negative 3, negative 1, my point 1, 0, my point 5, 1 to write the equation in point-slope form. So let's go with the x-intercept. That one stood out to me right away, so my point is at 1, 0. My slope is 1/4, so if I put them together in point-slope format, it would look like this, and I'd pause and say, okay, can I simplify? Well, y minus 0 is just y, so I could write it as y equals 1/4 times the quantity x minus 1. If I wanted to use the point 5, 1, I would have y minus 1 equals 1/4 times the quantity x minus 5. If I wanted to use my point here at negative 3, negative 1, I would have y plus 1 equals 1/4 times x plus 3. So now going to our next objective, we've got some situational pieces. It says, as part of a physics experiment, June threw an object off a cliff and measured how fast it was traveling downward. The table shows a partial list of the data she collected as it fell. We want to write an equation to represent the speed of the object over time. So again, that's our clue as to how we're writing the equation. What is your input? What is your output? Your x, your y, your independent and your dependent variables. If I'm trying to write an equation to represent the speed of the object over time, time would be your independent variable, your x, your input. Speed is your dependent variable, your y, your output. So what I want to do is now calculate my slope, the rate of change. And so I can use any of these data points and find the change in y over change in x. So that means I'm comparing 9.9 to 5. So 9.9 minus 5. 14.8 minus 9.9, 19.7 minus 14.8, and I can look at all of those differences here. In terms of time, I'm comparing 0.5 to 0, so 0.5 minus 0, 1 to 0.5, 1 minus 0.5, 1.5 minus 1. And again, I would compare the differences I have here to the differences I have here to find my rate of change. And so I can see that these were 4.9, these were 0.5. So when I compare 4.9 to 0.5, that's 9.8 meters per second. So I have the slope, I have the rate of change. Now, I'm going to look for either a y-intercept, or I'm just going to pick one of these points from the table and put it into my point-slope form equation. Remember, when looking at a table, you can identify the y-intercept pretty quickly by finding the input of 0, an x of 0. And I can see that's happening here at 0, 5. So I could quickly write this equation in slope-intercept form. I have my slope of 9.8. I have the y value for the y-intercept at 5. So I have an equation of y equals 9.5x plus 5.0. I also have all these 3 other data points. I could write it in point-slope form. Y minus the y value equals the slope times x minus x. So I could substitute any of these y's here. I could substitute any of these x's here as long as it's the pair and write my equation. So for example, I could have y minus 9.9 equals 9.8 times the quantity x minus 0.5. I could have y minus 14.8 equals 9.8 times the quantity x minus 1. Or y minus 19.7 equals 9.8 times the quantity x minus 1.5. Here we've got Lewis beginning a new workout today and keeping track of the calorie he burns at his run. He figures out after he runs 20 minutes, he burned 320 calories. He checks again at 45 minutes into his run and he's burned 720 calories. We want to write an equation that finds the number of calories Lewis burns is dependent on how many minutes he runs. That last sentence is very important because it's telling you what depends on the other. The number of calories burned depended on how many minutes. So if calories depends on minutes, calories has to be the output, right? And your minutes are the input. So if it helps you, you can make a table of values to represent that. If you just kind of want to label time as x, calories as y, that's up to you. But again, we need to find the rate of change, the slope, and either a point or a y-intercept. So I'm going to look at the difference of the calories burned compared to the difference of the time to find my slope, which ends up being, right, 400 compared to 25. That's going to be 16 calories burned every minute that he is running. I don't know my y-intercept because at time 0, I would need to know that. So it's faster just to put in one of these data points into your slope-intercept format. So our 16 is going to go here, and I could use this point, 20 in for x, 320 for y, and I could write my equation as y minus 320 equals 16 times your quantity, x minus 20. I also could have done the same thing with your point, 45, 720, and you'd have the resulting equation. Again, the 16 means, though, 16 calories burned every minute he was running. Last one is kind of a flashback to your last learning check. It says we want to graph, or the student was asked to graph the line y equals -3 has x plus 4, and that's what's appearing on the graph there. And there is an error there. We want to describe what the error is and fix it. So if we look at the equation, we see it's in slope-intercept form. It's saying our slope should be -3/2 going down 3 and to the right 2, and our y-intercept should be at 0, 4. If I look at my graph, my y-intercept is at 0, -4, and I'm going up 1, 2, 3, and to the right 1, 2, 3, 4. So there's an error in both the slope and the y-intercept. So again, the y-intercept should be at 0, 4, so that would be here. And I can see the negative, it's a decreasing slope, so my line should be going down 3 and to the right 2. And our line should look like that, and there are our 2 errors. So with the rest of the time remaining, you're going to work on your other practice problems. Again, your jumbled answers have been provided on Class Kit. They are also here at the end of the video, and you can go through and check off to make sure that you are on target. Again, if you are using Class Kick, please follow the directions on how you need to enter in the equations for it to check correctly.